Sometimes the most important discoveries happen when you are not even looking for them. Imagine you are a graduate student, peering at a video screen. The screen shows a live feed from a robot deep under the ocean. You are probably looking for something specific, maybe a strange rock or a new type of fish, but then you see it. A stream of bubbles rising from the seafloor. This was exactly what happened to a very observant graduate student. They were watching footage from the Pacific Ocean, about 50 miles off the coast of Oregon. The bubbles were a clue, a sign that something unusual was happening below the mud and sediment. The initial thought was that it must be a hydrothermal vent, but as scientists would soon find out, this was something else entirely. This was a discovery that would change our understanding of the immense forces at play beneath our feet. Scientists called it Pythia's Oasis, named after the ancient Greek oracle Pythia. Unlike a desert oasis that gives life-giving water, this oasis was taking water in. This simple observation of bubbles marked the beginning of a fascinating investigation. To understand why a few bubbles are so important, we need to zoom out a bit. The Earth's surface is not one solid piece. It is broken up into giant slabs called tectonic plates. These plates are constantly moving, but very, very slowly. Sometimes they pull apart, slide past each other, or crash into each other. The place where Pythia's Oasis was found is one of these crash zones. It is called the Cascadia Subduction Zone. Here, a dense oceanic plate called the Juan de Fuca plate is being forced underneath the much lighter North American plate. This process is called subduction. The plates get stuck, bend, strain, and build up an incredible amount of stress over hundreds of years. This is the engine that drives the biggest earthquakes in the world. Scientists discovered that the water at Pythia's Oasis was being sucked into the seafloor. The water is seeping down into the fault line, right where the two tectonic plates meet. It is much warmer, about 9 degrees Celsius warmer than the surrounding water. This warmth tells us that the water is coming from deep within the Earth's crust. This water acts as a lubricant, reducing the friction between the plates. The high pressure of this fluid helps the plates slide past each other more easily. The amount of fluid pressure within the fault zone can determine whether the plates are slipping along quietly or are locked together. Pythia's Oasis is a window into this hidden lubrication system. It reduces the friction between them. This is a critical detail. So we have water acting as a lubricant between two giant, grinding tectonic plates. This might sound like a good thing. Less friction seems better, right? Well, it is a bit more complicated than that. The scientists who discovered Pythia's Oasis are actually quite concerned. They believe that this leak, this oasis, is releasing fluid that would normally be trapped in the fault zone. If the fluid pressure drops, the lubricant disappears. The two plates would no longer slide so easily. They would press together with unimaginable force. When the plates lock together, the friction increases dramatically. The Juan de Fuca plate continues its slow, relentless push underneath the North American plate. All that energy has to go somewhere. The North American plate begins to bulge and deform, storing up stress like a giant spring being compressed. Eventually something has to give. The plates will suddenly, violently slip. This sudden release of hundreds of years of built-up stress is what causes a megaquake. The fault ruptures, and the plates can move by tens of feet in just a few minutes. To truly grasp the threat posed by the Cascadia subduction zone, we only need to look at history. The Earth has a long and violent memory, and it has shown us what a magnitude 9 earthquake can do. The largest earthquake ever recorded by modern instruments struck Chile in 1960. It was a magnitude 9.5 event. The earthquake also generated a powerful tsunami that raced across the entire Pacific Ocean. Geologists know that the Cascadia subduction zone has produced such earthquakes in the past. By studying sediment layers and historical records, they have found evidence of a massive magnitude 9 earthquake that struck the region in the year 1700. The 2011 Tohoku earthquake in Japan is another stark reminder. This magnitude 9.0 earthquake and the resulting tsunami were devastating. It showed the world how modern infrastructure can fail when faced with the full force of nature. If you're finding this deep dive fascinating, smash the like button and subscribe to the channel for more incredible science stories. When the bubbles of Pythia's Oasis were first spotted, the most logical guess was that they came from a hydrothermal vent. These vents are one of the most exciting features of the deep ocean. They are essentially hot springs on the seafloor. Superheated water, rich in minerals and gases from the Earth's mantle, gushes out of cracks in the ocean crust. These vents are not just geological oddities, they are bustling hubs of life. So it was perfectly reasonable to think that the bubbles at Pythia's Oasis were a sign of another one of these amazing ecosystems. However, when scientists took a closer look with their robotic submarines, they realized something was off. The water was warm, but not scorching hot like a typical black smoke event. More importantly, the chemistry of the water was different. Pythia's Oasis was not a vent spewing material out from the Earth's depths. The discovery of Pythia's Oasis reminds us that the ocean floor is a place of profound mystery. It is a vast, unexplored landscape that holds countless secrets. While the oasis itself is a major geological find, it is just one of many strange and wonderful things we have stumbled upon in the deep. For instance, in the Atlantic Ocean, not far from the Azores Islands, scientists have found rows of mysterious, neatly aligned holes in the sediment. They look almost man-made, like someone took a stick and poked a perfect line of holes, each about 4 inches apart. What could create such a pattern, 2 miles below the surface? No one knows for sure. These strange holes are a perfect example of how little we know. We can send robots to Mars, but we still have not figured out who is digging tiny, perfect holes in our own backyard. Geologically speaking, it is a humble reminder of the work that still needs to be done. And it is not just strange natural formations. It is a rather astonishing fact that we know more about the surface of the Moon and Mars than we do about the bottom of our own oceans. It is often said that only about 5% of the ocean has been explored, and even less of the seafloor has been mapped in high detail. The remaining 95% is, for all intents and purposes, a new world waiting to be discovered. The challenges are immense, the pressure is crushing, the darkness is absolute, and the environment is incredibly harsh. But the potential rewards are equally enormous. Every time we send a submersible or a remotely operated vehicle into the deep, we find something new. On a recent expedition in the Pacific, scientists collected over 30 potentially new species. Each new species is a new chapter in the book of life. It helps us understand evolution, adaptation, and the incredible diversity of life on Earth.